Ever wonder why your phone call doesn't drop when you're driving at 100 kilometers per hour? It's because of 4G handover. Your phone seamlessly switches between cell towers. First, your phone constantly measures signal strength from all nearby towers. When a neighbor tower's signal becomes stronger than your current tower, the network makes a smart decision to prepare the handover. The handover executes in milliseconds, so fast you never even notice. Want the full technical breakdown? Watch the 8-minute version. Like and subscribe for more telecom tutorials.
The handover executes. Your connection switches to the new tower in just a few milliseconds. Handover completes. Your phone confirms the new connection and releases the old tower resources. This entire process repeats continuously as you move, ensuring seamless connectivity wherever you go. Key parameters like A3 event, hysteresis, and time to trigger control when and how handover happens efficiently. Without proper optimization, handovers can fail, causing dropped calls, ping-pong effects, or poor call quality. With optimized handover, you enjoy uninterrupted calls, smooth video streaming, and reliable data anywhere. Now let's explore the critical parameters that network engineers use to optimize handover performance. The A3 event is triggered when the neighbor cell signal becomes better than serving cell by a specific offset. This offset is typically set between 1 and 5 decibels, depending on network conditions and requirements. Hysteresis adds a buffer margin, ensuring the neighbor cell is significantly better before triggering handover. Without hysteresis, small signal fluctuations cause ping-pong handovers, wasting network resources and battery power. Time to trigger requires the handover condition to remain true for a specific duration before execution. This filters temporary signal variations caused by obstacles, interference, or brief environmental changes. Setting the right time to trigger value balances responsiveness with stability for optimal handover performance.
Handover margin is another crucial parameter that determines the exact timing of the handover decision. The margin defines how much better the neighbor cell must be before handover is considered acceptable. Proper margin settings ensure handover occurs in the optimal overlap zone between cells for best performance. Cell reselection works similarly to handover, but applies when your phone is in idle mode without active calls. While handover maintains active connections, cell reselection prepares your phone to receive calls from the best cell. The network ranks all available cells based on signal quality, priority, and load to select the best option. All these parameters work together in the handover algorithm to make intelligent decisions millisecond by millisecond.
There are several types of handover in 4G networks, each serving different purposes and scenarios. Intra-frequency handover is the most common type, switching between cells operating on the same frequency band. Inter-frequency handover moves your connection to a cell on a different frequency, useful for load balancing. Inter-RAT handover switches between different radio technologies, like from 4G to 3G, for continuous coverage. X2 handover uses direct connection between base stations, providing faster handover with minimal interruption, as one handover routes through the core network. When direct connection isn't available between base stations, each handover type has specific advantages, making them suitable for different network scenarios and requirements.
Even with proper configuration, several common problems can affect handover performance and user experience. Ping-pong handover occurs when a phone switches repeatedly between cells, wasting resources and draining battery. This usually happens when hysteresis is too low or cells have excessive overlap without proper parameters tuning. Too early handover switches before the target cell signal is strong enough, often resulting in call drops. Too late handover keeps you connected to a weak cell too long, causing poor quality before switching. Handover failures can occur due to network congestion, interference, or insufficient resources at target cell. In real networks, multiple problems often occur together, requiring systematic analysis and optimization.
Let's explore proven optimization techniques that network engineers use to solve handover problems effectively. Increasing hysteresis reduces ping-pong handover by requiring stronger signals before triggering the switch. Optimizing time to trigger filters temporary variations, ensuring handover only occurs for sustained signal changes. Physical optimization, like antenna tilt adjustment, can improve coverage overlap, creating better handover zones. Maintaining accurate neighbor cell lists ensures your phone knows about all available handover candidates. Load-based handover parameters dynamically adjust to balance traffic across cells for optimal network performance. Proper optimization significantly improves key performance indicators like handover success rate and call quality.
In the real world, handover optimization must handle diverse scenarios, from high-speed trains to indoor buildings. High-speed scenarios require specially tuned parameters to handle rapid cell changes without dropping connections. Dense urban areas present challenges with many overlapping cells, requiring sophisticated handover algorithms. Animation showing indoor-outdoor handover scenario. Signal penetration challenges. Small cells and macro cells coordinating. Hybrid network visualization. As networks evolve to 5G, handover becomes even more critical with higher frequencies and advanced features. Remember, successful handover requires proper measurement, smart decisions, and well-optimized parameters working together. Thanks for watching. Subscribe for more telecom tutorials and check the description for advanced handover optimization guides.